Welcome back, Math 10 students. Mr. Tronis here. We are going to start Unit 5. Sorry, drink of water there. On linear functions. So this is going to be a 5-section unit. It's got lots of practice in it. You're going to be able to graph lines way faster than you could in Unit 4. We're going to learn some strategy here, a couple different forms that are called slope-intercept, slope point, and standard form all have their uses when needed. The big one we're going to use the most, though, is y equals mx plus b, this one, with this cheesy little one-liner joke. So let's dive into our first lesson on 5.1. What the heck is the slope of a line? We've already seen this a little bit in the previous unit. And so the slope of the line is describes basically the slant, or some might call it the steepness of a line. Okay, it could be steep going up or steep going down if you're looking at left to right. So there are 4 different types. So a positive slope is one that increases as we follow it always from left to right. Negative slope is the opposite. It decreases when we follow it from left to right. Okay, so still going left to right, but it goes down. So the line for a positive slope is going to be going up like so as we go from left to right. Negative slope is going to be going down. And then we have one called the zero slope. So all points have the same y coordinate. In other words, we have a horizontal line. Okay, so a horizontal line looks like so. As straight as I can, straight. This is called our zero slope. And then the undefined slopes. And we'll understand why it has these 2 names in a moment, but this is the opposite of the zero slope. All the points have the same x coordinate, so this would be our vertical line. Okay, so that's going straight up and down. Okay, and in all of the equations we're going to be using, we're going to be denoting the slope with the letter m. M stands for slope of a line. And we can choose any 2 points on a graph, okay, whose coordinates are integers, and we can calculate the rise and the run. So the idea is our slope, okay, this is m, we can figure out what's changing. So what's the change in up and down? What's the rise? And then we divide it by what's the run. And this should ring a bell because we did do this. It's the exact same thing as rate of change. Okay, this was the same thing as saying, let me reference this plus minus over here. So plus would be up, negative or minus would be down, and plus here would be to the right, and left would be negative. Okay, whoops, left. Okay, and now just to recall, this is the exact same thing as what we learned before, the change in y divided by the change in x, the change in the dependent variable divided by the change in the independent variable. It's the exact same thing. And so let's take a look at a few graphs here, and we're going to determine the slope. And when we have a graph, it's really easy. Just pick any 2 points that this graph falls on. So we like to pick points that it falls on perfectly. Okay, there's one right here and one right here, these 2 coordinates. And now we're just going to figure out our rise over run. So remember, m is equal to the rise divided by the run between 2 points. So we look at our 2 points here. Let's start always going left to right is the easiest way to do this. Let's get our rise in between these 2. So it looks like it goes up 1, 2, 3, 4, 5, 6. So we're going up plus 6. And then if we go to the right from here, we're going 1, 2, 3, 4, 5, 6, 7. So this is plus 7 because we're going to the right. Okay. And so this gives us a slope of the rise being positive 6 and the run being positive 7. Now we could have gone the other way. I just think we should reference this really quick. I'll just take a second, but I could have gone down Okay, I could go down 1, 2, 3, 4, 5, 6. That'd be, if I went this way, that'd be -6. And then if I went to the left, 2, 3, 4, 5, 6, 7. Okay, that's -7. Now, the rise over run, I can still calculate it this way, but that's the exact same thing as -6 divided by -7, and we know two negatives make a positive. So it doesn't matter which way, but it's good to have the same strategy every time. So find 2 points and find the change in the rise and the change in the run, and that'll create a fraction for you. Let's take a look at B here. We have a unique situation. Let's pick any 2 points here. Let's pick, say, this point and this point. Okay, they fall perfectly on the grid. And we see that our rise in this is 1, 2, 3. We have +3, okay, is our rise. And our run, though, is 0. It doesn't change at all. So we're going to set that up as m is equal to the rise over run, so 3 divided by 0. But that's a problem. You cannot divide by 0. You can't divide by 0. Therefore, this is the slope that we were talking about, and we say is undefined. Undefined slope, because you cannot divide by 0, or vertical line. Next, let's take a look at this one. So let's pick any 2 points. Right here, we have a point, and it looks like right here we have another point. So let's get our rise first. Let's go to red. Our rise is going to be going down. It looks like 1, 2. So that's -2 is my rise. And then my run, it looks like it's going 1, 2, 3, 4. So +4. So we're going to get our rise is equal to -2 divided by, I said +3. 1, 2, 3. Said 4 and I wrote 3. So +4. Now, of course, we would reduce that always. Reduce our slopes to divide by 2 to -1/2. So just a little note here. Reduce, please. There's our slope for that one. Next one here, we'll pick any 2 points. Doesn't fall perfectly on a grid line, but it doesn't matter because we're going to see a situation here that our rise, in this case, our rise is 0. Okay, there's no change in the rise, and our run is +2. Okay. Now, this is a situation where anything, if 0 is divided by anything, you still get 0. So this is the case of the 0 slope, or just m equals 0, as simple as that. All right, and down here, we can get a bit of an idea, like positive slopes rise up and run to the right, or they can go the opposite. You can drop, okay, negative, and run left to get the double negative. So we get a positive slope with 2 negatives or with 2 positives. And negative slope can have 2 different combinations. We can rise up, then run to the left, okay? Or it could drop down, then run to the right. So you pick your strategy that you like best, but I generally like just working my way left to right between 2 points. Okay, slope can be calculated from 2 points on a line using this. So this is really handy when we don't actually have a graph, but this graph, this little picture shows us what's actually happening. We can figure out our slope again, which is the change in y, the rise. Okay, so this is our this is our rise right here. So we can take one y value and subtract it to find the rise, the difference. And then we can take the second x value and subtract the first x value, and that's going to tell us the run. And so we can see that right here. If here's our 2 points, there's a lot going on here. Here's point A and point B, okay? And so we can find the two y values. We have y2 and y1. And so that's this height, and we can subtract them to get the difference. That's what's in brackets here. So I can get this rise by subtracting the two y values. And then if I know the two x values, I can subtract them to figure out my run, or my change in x. So again, to find the change in something, we're just subtracting from one point to the next, but we're matching x's with y's. Now, this is really handy, like I said, when you don't actually have an actual graph, and you can just count the rise over run like we did in the last example. So here we have some questions. We're just going to be, you'll be given this formula. You can use it for all these questions, but first we're just going to label it. So this is my point number 1. So I'm going to call this x1, y1. And this is point number 2. So I'm going to color code this. I'm going to call this x2, y2, because this is point number 2. Okay, so the way to think about it, this is point 2. And this, we'll go back to green. This would be point 1. Okay, so now let's use our formula. So this is what it looks like. Let's go to blue. So I take my m, and my m is equal to y2 minus y1, the 2 y values subtracted, and the 2 x values subtracted. Just make sure you line them in the right positions. So the way I like to do it is, let's just create empty brackets for all of our values up above. Can't go wrong this way. And now I'm going to enter in my my x2 and my y2. So based on this formula, y2 is 9. I get that from right here. And x2 is -3. Okay, and then let's put in my other 2 values. My y1 is -1, and my x1 is +2. Okay, and now let's just be really careful when we combine these integers. So we're going to simplify top and bottom and then simplify the fraction if we need to. 9 plus -1, that's the same as addition. So this is the same as 9 plus 1. And down below here, this is -3 minus 2. There's no double negative this time. So we're going to get 10 over -5. And that's the equivalent of -2 over 1. Let's always write our slopes as a fraction. So it's 10 divided by -5 is -2. Put our negatives up top. So there's our slope. Next one here. So let's label it. I'm going to move away from color coding. So we can go x1, y1. And this will be x2, y2. Label our points. Now let's set up our equation. M is equal to the y's being subtracted, y2 minus y1, and the x's being subtracted. I'll change colors here. So let's put in the y2 is -4, subtracting the other y value is 5. And my x value is 4, and I'm subtracting 4 on that one as well. And you're going to see a situation here right away. Simplify first, and we're going to be left with 4 minus 4. Of course, this is -9 divided by 0. We cannot divide by 0, so this is undefined because of that. Okay, cannot divide by 0. Okay, let's do another example here. Again, we're going to say our slope m is equal to our y value. So I should label this first, x1, y1, that's point 1. Point 2 is x2, y2. Okay, so let's subtract our y's, and then we're going to subtract our x's. So our x2 y2 is -1, subtract our y1. So -1 minus 4. So I always kind of look at it like this. And then we go like so with 3, subtract -5. Simplify that. I have -1 minus 4 divided by 3 plus 5 because of the double negative. And so that's going to leave me at -5 over 8. That is fully reduced, and that is our slope. Okay. Slope of a line segment. So this is a little bit more of an advanced question, but we can handle this. We're told the slope is right here. That's our m, is 3 over 2. And we're given 2 points, except we don't know one of the values. We don't know this particular x1. So I'm trying to solve for x1. So this is x1, y1, and this would be x2, y2. So let's set up our equation. So recall, let's just write their equation for finding the slope between 2 points. We have y2 minus y1 divided by x2 minus x1. And now let's fill in what we know. M is 3 over 2, and that's equal to y2. So I'm going to subtract this, 2 minus 8. So we have 2 minus 8. Okay, and then on the bottom, this is where I have -1, and it's subtracting k. Well, let's simplify this a little bit. Get rid of all those brackets. So we got 2 minus 8, that's going to give me -6. And down below, I can't do anything yet. I cannot solve for k when it's in the bottom. So the strategy here is what we call cross multiply. Whenever you have this situation, you can get rid of your denominators by cross multiplying. You should have seen this before, but basically the idea is I'm going to multiply both sides by 2 and both sides by -1 minus k. So over here, I'm going to multiply by -1 minus k. Okay, and this is called cross multiply. Oops, cross multiply. And we have to do this when we have to solve for what's on the bottom here, or get rid of two fractions when they're equal to each other because they are equivalent. And over here, I'm going to multiply by the 2. Okay. When we do that, everything actually cancels. So this cancels, and we're left with what's up above here. So we're going to have essentially 3 multiplying that bracket, -1 minus k, is equal to -6 times 2. Okay. And then let's multiply that in. We know how to do this. Is -3 minus 3k is equal to -12. And now we need to solve this for k. So we need to isolate k. So we're going to put up a fence here. You've seen this before. We're going to add 3 to both sides. That's going to cancel the add 3. I'm going to have -3 times k is equal to -9. And now we're going to divide both sides by -3. And that's going to leave me with k is equal to +3. So therefore, my k value is +3. So a lot going on here in this last question, but we just used the equation, substituted in the values, and then we had to solve for k. We used a special strategy called cross multiply, and that will allow the fractions to go away here. I'll go into more depth on this in class, but essentially I'm multiplying both sides by 2 and both sides by -1. So maybe I'll show that here. I'm multiplying by 2 here as well, and that's why this 2 cancels with this 2. And then over here, I'm also multiplying by -1 minus k. And this is why cross multiplying works. They cancel the denominators on both sides, and I'm left with just a multiplication on both sides. No more division, no more fractions. Okay, so that's what we learned in this first lesson. We learned about what the slope of the line is. We have 4 different types of slopes. Positive, negative are the majority of what you'll deal with. Sometimes a 0 or an undefined slope. We looked at them graphically, and then we learned how to determine slopes when all we know is 2 given points and when one is a variable. We'll see you next time. Bye.